Hey guys, welcome back to AlgoYogi. We are doing linked list series. Our next problem in the list is reorder list. Let's visit the problem on LeetCode. It says you are given the head of a singly linked list. The list can be represented as L0 at node 1 and blah blah blah, L minus 1 and Ln. So that's basically representing the number of nodes, which are n or n plus 1 you can say, because it's starting with 0, but that doesn't really matter. We need to reorder the list to be on the following form. How we are reordering? We're going to take L0 and its next pointer, instead of setting to L1, we're going to set it to Ln, and then Ln will set its next pointer to L1. So basically we are taking the first half and the second half of the singly linked list, and we are basically mixing their nodes in such a way you take one node from the list first half, and then you take one node from the second half, but they have to be in that opposite order. So second half needs to be reversed. You know what I mean? Because you're basically taking it, traversing it from the back. So if you can see in the first example though, let me just switch the view and show it over here. So as you can see, in our first example, we have this list: node 1, node 2, node 3, node 4. So what we have done, we've taken, basically let's divide this into two halves first. First is this and second is this. Although we could have done it in a way where like we're pointing, in the back, in the front, taking one from front, taking one from back, and then combining them together. But just, I think this way it would be easier to imagine. And then we're gonna reverse this. So reverse second half. What do we get after reversing it? This is what we get. Then we take one node from here and one node from here, and then basically append them. Basically not append them, this node comes from here, this node comes from here, and they basically, first node points to 4, and then fourth will be pointing to the node from the first list, and then second node from the second list. All right, so it's basically taking the first half, second half, reverse second half, and then basically just take one node from each list and then just place them right next to each other using the next pointer. So how are we going to solve it? There are a couple of ways. One of the way is big of n time complexity and big of n space complexity, and in that way we will take our list, store it into an array 1, 2, 3, and 4. Then what we do is we have this pointer I, and then we have this pointer j, and then we basically iterate until I is lesser than j, so that we are not mixing them. And then we keep doing, we create like basically the list node, and initially, because we are using it from the first half, so we'll create a head. We can call it dummy head, but that doesn't really matter, and set the pointer to basically we will create one that will come from ith, and then that will point to the jth node that coming from here. Then I will basically move forward to this place, and then j will move backward one place. So j will be over here, and then we use ith pointing next. So that is basically pointing to our second node, and then we point using j to 3. This is what we get. I think you can see now, sorry about that. And this is what we get, and we just return the reference to the first node that we just created. We could call it dummy or anything, and then we just return the next pointer of the dummy, which will point to this node. That's one way of doing it. but that is using big of n time complexity and big of n space complexity. And the question is, can we do better? This is an easy solution. You can write it yourself, converting the entire list to an array and then using 2 pointers, creating a dummy node, and then just traversing these together, taking one first node, the node from the first list, basically the ith pointer, second list, basically the jth pointer. This way you wouldn't have to reverse or anything, just keep moving pointers together and keep making this new list, return the head of the list that you've created, the new list. But I have a better solution for you guys, where we will not require this space at all. We will use constant space. So how do we do it? We know that this list, in order to create this final list, what we are actually doing is dividing into 2 halves, taking the first list and taking the second half, reversing the second half, and then merging these two together linearly in the same order the elements occur. So I basically will visit these nodes, and one by one I will merge them into my list 1. So I will take 1, and in place of this pointing to 2, it will point to 4. That comes from here. I've already explained it, so I think I'm just like going over again, and this comes from here, and this is what we will return. So what we are actually going to do is find out the middle pointer from our list. First is basically reaching the middle of the list that we can use that we can do using slow and fast pointer. Initially we will basically find the middle of the list, and we know, like, using, let's point fast, slow over here, and then fast we can start from the next this time, because we want to stop one node before actually the middle so that we can remove the reference. So that's what we're going to do. And then once we find the middle, fast will be gone. Then we remove this reference, but at the same time save this node as our second list. So now this is gone, this thing is gone. We have two lists, this and this, and then finally we reverse it. We know how to reverse a list. We have done it a couple of times. After we are done reversing, we will have a previous pointer pointing to this as head, 4 as head, so prev, and then we're going to start over here calling it current pointer, and then just merge this particular into this, and then return the final list. I know, a couple of steps, but I promise you, when we write the solution, it's going to be a piece of cake, because it's going to be straightforward, just doing whatever we have understood so far. So we're going to find the middle of the list. So slow and fast, initially they both can point to head and head, because it doesn't really matter. Sometimes it's even odd, but we just want to find we want to stop one node before the next middle to the next node. So it will either be at the middle or one node next, but it doesn't really matter, or one node previous. While we can say I am gonna use fast pointer, so that because fast is gonna reach the end of the list before slow. So fast and fast dot next, because it moves 2 pointers, so we want to have the fast pointers next also available before we proceed this further. Slow and fast, they will both be slow dot next, and fast will be fast dot next dot next. Alright, once we come out, then fast, we don't care, we just used it to find the end of the list so that our slow is in the middle. Now I'm gonna store this second list is pointing to slow, and then I want to remove the reference, next node reference. Slow dot next will be none now, so that it's not pointing. Now we are separating both of these lists. Now we have two lists. The second one, which start from second list, we're gonna reverse it. So I'll have my current pointer pointing to second list. All right, I know it's like kind of, but this is the way I like to do it. If you remember the way we will write the reversing the code, I could simply assign this over here as well. It doesn't really matter, it's okay. Although, you know what, let me do it for you guys, because at the end of the day we don't really care about this. We just want to reverse the list, and at the end of the day previous is what remains with us. That will represent the head of the reversed second half of the list. All right, sorry. So pre will point to none initially, then we're starting while loop, while cur. We're gonna have a next pointer pointing to current.next, and then we're gonna have cur.next pointing to prev, and then prev pointing prev. We want to assign current to prev now, because prev will go to current, so that current is now the second node that it needs to point. It needs to point from, I guess. So not point from, sorry, point to. So prev will point to cur, and then my cur will be next, because I'm looping over to the reference that I just removed using this. And I saved the temporary. I could have called it temp also. Let me call it temp. I think temp is better. You know, we are storing that temp reference, and then at the end of the day, once this is done, we will have our prev node as pointing to the second half of reversed list. Now I want to take the second list, and I want to take node by node and merge it into my first list. So I will say while, I'm going to call it prev, while it's a valid node that we're processing, I want to take the reference from both nodes. So first node will be basically coming from head. So let me take it as, again, first, you know. So let me call it first and second. They're both pointing to, first is pointing to head and second is pointing to prev. All right, and while second, so that it's easier, right, easier to follow. So while second remains valid, second list remains valid, or the pointer we are pointing, the node we are pointing to, until then we're going to keep processing, taking the one node from second list, merging it to our first list. So I'm going to have some temp first and temp second, taking it the second node reference from first and second. So these two, dot next. All right, now I will point my first next pointer to my second node. So that comes from the second list, second. Now it has pointed there. What second want to do is point second's next node to the first temp, first next, which comes from first is next. So second dot next is pointing to my temp first. All right, and then what's going to happen is my first has pointed, my second has pointed, but now I want to move my second to my second dot next. All right, so I'll move my second to second dot next because I'll be processing it again, and my first I will point to, I've done first dot next to second, and then where do I want to point my first to? Temp so it will be pointing to again to the node that remains in the as part of the itself. Yes, so it will be temp first. All right, Okay, let's, you know what, and then we can just return head. Let's understand it better on iPad. You know, I think it's a really awesome pointers play, but we just want to understand it better. So what we have actually done is, now we have these two lists. First is 1 and 2, and then I have second as 4. Remember, we reversed them, so 4 and 3. Now I'm gonna since I'm merging this to this, then I have these pointers, first and second. What I do is, until second remains valid, I am storing this temp reference, like this. So my temp second, let me just call it like that, and then my first temp first. All right, then what I did, I took away this pointer and I pointed my first dot next to second. Remember, we have done that in the code, right? That's what we did. So top right, you can see this is what I did. Right now I'm gonna take second and second dot next. I'm basically removing this pointer, and second dot next I'm pointing it to first temp first. All right, second dot next goes over here, and then what I did is take away my second from here, and I am pointing my second to basically my temp this temp second, because I don't want to lose this pointer. So second will point over here, so this will go away, and then I want to move my first to temp first. All right, so first, instead of pointing over here, now this will be pointing to here, and this will go away because its use is done. So now again, if you see, one of the node has been merged into our first list, because if I am redrawing this, so what I will see is my first list becomes 4 pointing to 2, and then my second list is this second, and this is first. So we just moved around so many pointers, and at the end of the day we are doing exactly what we were gonna do. So this is almost ready, and one node remains to merge, and that will be merged in the second loop, since the second remains valid, and it remains valid for this case. So as you can see, this is great, and let's run it, and hopefully I'm gonna zoom out, and hopefully this runs. Unless there is something that we forgot to do somewhere, which appears it to be. What is it that we have forgot to do? Dot next, second dot next, first dot next points to second. That's what we want. Second dot next points to yep, and second points to second dot next. This is what we don't want. Second, we want to point to this thing, temp we stored. So this is what we're gonna do. All right, since these pointers, we were playing around with the pointers, that's not what we want to do, and I think this wasn't needed, I guess, unless it causes a problem. Hopefully it shouldn't. Maybe actually it did. Yep. All right, so this is the refreshed again code. I'm gonna submit it, and I think this is all good. So see, I think these debugging thing, it might seem that, you know, why it took me time, and you know, he doesn't really know, but it's like, if I'm debugging right next to you guys, like, please know you will also be doing it when you write your own solution, because at the end of the day, it's you writing code and you will make a lot of mistakes, just like I'm doing. But anyway, I don't expect myself to be too smooth, and I'm just doing it to learn myself and also do it publicly. All right, then let's write down the time complexity. Time complexity would be big of n, and space complexity we reduce down to big of 1. Complexity big of 1. Let's go back to AlgoYogi, mark this solved, and see you guys in the next problem. Until then, bye bye.